Welcome. We will do another example of calculating first and second order partial derivatives. This time we are going to find the first and second order partial derivatives of the function x power y. Earlier we did the first order partial derivatives. Remember that when we are differentiating with respect to x, we treat y as a constant. So think of x power y as a power function, variable to a constant power. But if I'm differentiating with respect to y, then I treat x as a constant. So I have constant to a variable power, so I treat it like an exponential function. We have to do the same thing when we do the second order partial derivatives. If I differentiate with respect to x, I just use the power rule. I get y x to the power y minus 1. When I differentiate with respect to y, I use the exponential rule. So I get the exponential times ln of the base times derivative of the exponent. So x power y ln x times 1. D squared over dx squared means first with respect to x, again with respect to x. So I differentiate this with respect to x, which means I treat y as if it's a constant. So the first factor, y is a constant factor, I keep it as it is. I need to differentiate x to the power y minus 1 with respect to x. Since I'm treating y as if it's a constant, I have the variable to a constant power. So I use the power rule. So the constant factor y times old exponent y minus 1, the variable to the power exponent 1 less. Y minus 1 is y minus 2. So altogether I get y times y minus 1 times x to the power y minus 2. If I find d squared of xy over dy squared, I take d over dy of that is x power y ln x, differentiate that again with respect to y. Now I treat x as if it's a constant, which means ln of x is a constant. I have to differentiate just x power y with respect to y. It's again just exponential rule. We already know the answer. So I'm just going to get derivative of x power y times the constant factor ln x. This ln x came from logarithm of the base here. This ln x was the constant factor that was already there. Of course, you can also write this as x power y times ln squared x. Now we have the mixed partial derivative. Of course, it doesn't matter in which order we do this. We will do it in both orders and then verify they are the same. So I'm going to do it in this order first, differentiate with respect to y first, which gives me x power y ln x, and then with respect to x. Now I have the variable in both factors, which means I have to use the product rule. The first factor is x power y. If I differentiate that with respect to x, I'm going to use the power rule because I have a constant to a variable power. Remember that we are differentiating with respect to x, so I treat y as if it's a constant. Of course, we already know the answer to this. If I use the power rule, I get the old exponent times the variable to power 1 less, that's y x to the power y minus 1 times second factor ln x plus the first factor x power y times derivative of the second factor. The second factor is ln x. Its derivative with respect to x is 1 over x. We can simplify this a little bit. We will need to simplify to match the answer with the other order of differentiation. X power y times 1 over x is x to the power y minus 1. And so that gives us the final answer after simplification. If I had done it in the order of differentiate with respect to x first and then with respect to y, we know the derivative with respect to y is y x to the power y minus 1. And I have to differentiate that with respect to y. Of course, again, I have to use the product rule because I have y in both factors. The first factor is y, derivative of y with respect to y is 1, times second factor x to the power y minus 1, plus the first factor y times derivative of the second factor. I'm differentiating with respect to y, so I treat x as if it's a constant. So I have a constant to a variable power. So I have to use the rule for exponentials. I have the exponential times ln of the base times derivative of the exponent. The exponent is y minus 1, its derivative with respect to y is 1. This, of course, is the same answer that we got here. It's just that the two terms are in different orders. Again, we see that the two mixed partials are equal to each other.